hopefully you can see my screen.
Yep, seeing you the slide, so take it away.
Okay, yes, as Christian said, I'm Klaus. I'm the community manager at CrowdSec. And I've been an InfoSec professional for close to 20 years. Right? Yes. This is what I'm going to talk about today. First, I want to say something about how we've been looking at cybersecurity up until now, that it's really not complicated as such, that we've been doing it wrong, basically. And then I'll talk to you about why we think a crowd approach is the right way to do this better. Then we'll tell you a little bit about how the tool, that the CrowdSec open source tool, works, and then in the end I will go into a case study where you can use CrowdSec to beat DDoS with CrowdSec and Cloudflare. Yeah, sorry. Cybersecurity is, as some may think, it's not a complicated problem, because complicated problems, those are the one that needs a genius to be solved. And this is Einstein's theory of relativity, and that is complicated. Instead, cybersecurity is complex, and complex problems, that's a completely different ballgame. Those can be solved if you're working as a team. And what is hard, especially in cybersecurity, and definitely also when you're sending people to the moon, is there's so many things you have to make sure to remember and to have competences for, and that's hard, both in terms of mastering each and every one of the steps, but also to be able to do it right every single time. So basically, to sum up, complicated problem that can be solved by one smart person. For complex problems, you need a couple to collaborate. So we tried outpowering, that failed. We found outsmarting the criminals, that also failed. So instead we try another approach, which is outnumbering them. So instead of trying to be Rambo and fight against 1,000 enemies, and that only works in films anyway, we suggest a hive approach. So nobody wants to fight an entire beehive. So anybody in the right mind, they would just run away instead. And that's what we want the hackers to do. These are all examples of companies that has had so much money for cybersecurity, and yet they messed up. All of these has big budgets, large team, and extraordinary people to help them defend themselves, and yet they were hacked. One of these are JP Morgan. They had a security budget of $800 million per annum, and that's almost $1 billion. And I don't know about you guys, but I can't imagine that much money. So it's really not a matter of resources, because bottom line is the approach is wrong. And there's a reason why it's not solved. It's because defending is hard, really hard. Because time to patch, that's way too long. Maybe that's too much to patch, too few people to do it. Maybe your parameter is really large. Maybe it's open. Maybe it's even larger than it has to be. Who knows? And there's money. Money don't grow on trees, and many companies still don't take the risk of ransomware seriously. Will they ever? Who knows? So the thing with attacking is that is so much cheaper, and it takes a lot less resources. So, and unbeknowingly, many people make it easy to hack them by having, an unsecured device in the parameter, and then they're hacked, or they don't have anything installed on endpoints to protect them. Sorry. Oops. So, like the castle strategy that we used in the 80s, we have a big castle. We have a big grave around it. That doesn't work anymore because the parameter is all over the place. So, because the reality nowadays is that every company, even those who doesn't know it, they have some resources somewhere in the cloud. So it's not practically possible to protect everything from a central point. So instead, all resources have to defend themselves autonomously for this to work properly. So, and the way threat data should be shared across them is using HTTP, because that's a light protocol, and every device knows it. So we want to leverage IP reputation in the cloud to build the biggest, most accurate real-time IP reputation database. So you can think of us, or think of the tool, of course, as the ways of cybersecurity, and that's what we are building with this project. It is already the biggest crowdsourced ETI network in the world. Our founders, they all have a background in a secure hosting company. All developers and our CTO, they all have a background as pen testers. So we know how to build a secure infrastructure. The way CrowdSec works is that first, it collects the data on your host. It passes the log, and whenever there is something that looks like an attack, it's being sent to our hive mind, if you want to say that. The big inspiration here is fail-to-ban. We wanted to build a modern version of fail-to-ban, but then it ended up being way more versatile than fail-to-ban. I'll talk a little bit about that later. After logs are added, then threats are detected by the agent, and then logs from either locally or from the communities analyzed to detect if there's any malevolent behavior by our backend. Based on threat intelligence, bouncers, that's the second part of the software, they will remediate. Either they will block on firewall layer 3, or on the application layers, which is layer 7. So whenever bad traffic is detected, those findings are shared back with the community. So every other CrowdSec user, CrowdSec agent can use that threat intelligence. Theoretically, the tool can handle any scenarios that fail-to-ban can handle, but not yet in practice, because fail-to-ban is 20 years old and has had a supportive community for a very long time. So eventually, whenever we go big and it's more known, all those scenarios will come. But in theory, we can handle everything that can be described by YAML and passed by the graph. So our interference engine can handle some scenarios that are much more complex than what fail-to-ban can. We can handle an anti-DDoS scenario, which we will talk about later. We can also handle resource abuse, like we block an attacker's access to a website if they're trying to exhaust that website by mass scrolling. Also, we can ban an entire IP class if some, and that's by default 5, they have already been banned, then the whole IP class will just be banned, just like that. And of course, much more. These are just examples. And also what you can see on the screen are also examples of scenarios where CrowdSec can be used. To sum this all up, we think that cyber criminals, they've had it too easy for too long. So what we're trying to do here with CrowdSec is to shift the balance of power. We want people to be able to work together by sharing and collecting all this threat intelligence for the benefit of the entire crowd. So ultimately, we want to force the hackers to change their tactics or go somewhere else. The potential threat intelligence that's generated by CrowdSec, that is more real than others, because it's not simulated from honeypots. It's from real production servers all around the world that just has the CrowdSec agent installed. Because, as we say, you can't dodge the crowd. And as a bonus, the CrowdSec software is free, no matter what happens to CrowdSec the company. Worst case is that the code is forked, and then the community will simply move away. So the code alone, that's useless. It's only in combination with the community that it gets it gets its value. The backend is not yet open source, but that's mostly because it's not fully developed, and the code is really not that stable. It's not good to. It's stable, but it's not. We don't want to show it out. To show it to anyone yet. But we will eventually, because we really want to make it very visible how this decision process is working and how our decision engine is working behind the scene. Every IP that's in the database, they are thrown out after 72 hours. I'll talk a little bit more about the decision process, which we call the consensus engine, on the next slide. Every agent that sends rogue IPs to what we first call the smoke database, then based on this, we will determine which IPs are bad, and over time we also want to integrate this consensus engine and the IPs that comes out of it into any enterprise incident response process, so that IOCs they can be part of the triaging process that normally take place in a tool like for instance MISP. CrowdSec consensus engine that bases a decision on various criteria that are all combined. One of them is the regularity of the watcher. That's what we call a contributor or an agent internally. Also the consistency compared to all users' data and CrowdSec's consolidated statistics. They will correlate with CrowdSec's own honeypots and high reputation watches. I know I said before that data is from honeypots, but we do have our own so that we can control both ends of the system, so to speak. So we know which system generates which log, just to make sure that everything is working right. But there are a very small part of the entire IP reputation database. Then we're cross-checking this with third-party sources, and we're enriching the consensus process with information from other sources if that's possible. And usually when I talk about CrowdSec, people always want to ask if it's possible to poison our database. And yes, it's possible, but it's hard, because you really have to have an army of false agents, so to speak, that would consistently feed our database first with a lot of real data, and then you would have to like inject those bad or those fake attacker IPs into our data stream, and that's really hard, because you wouldn't even be sure if they would be selected anyway or be marked bad. And also there are IPs that you will never be able to ban, because we are whitelisting them permanently. Those are like CO bots and the CN partners, like for instance Cloudflare. We take GDPR and privacy very serious, because obviously that's always people's concern if they can remain anonymous. And the only thing that we send back is as little as we can to do a reliable consensus. So we only tie IP information to a randomly generated UID to uniquely identify the CrowdSec agent that has submitted those IPs. And right now, we're around 20,000 installs worldwide across 6 continents and 110 countries, as far as I remember. And we have, over time, we have detected and verified, or at least chosen that 700,000 IPs are malicious across a lot of different industries. And our goal is to be 1 million users in 2024. And that's a long way to go. Now I want to talk specifically about how to do layer 7 anti-DDoS with CrowdSec and Cloudflare. There is anti-DDoS built into Cloudflare, but this is, as you'll see in a short while, this is more effective. When we talk about anti-DDoS, there is at least 2 examples, and one of them is happening on layer 3 DDoS. That's not what we're talking about. We're talking about layer 7, the application layer, where this attack is going on. This is our setup. Is basically a WordPress server with WooCommerce that we set up on a VPS in AWS with 2 Xeon cores and 4 gigs of RAM. Then we found a DDoS as a service and basically hammered that on our site for 20 minutes, and this is what happened. You can see that on the screen. It went down, of course. And after 20 minutes, it had received 70,000 HTTP requests and from 1,150 unique IP addresses. And our approach to fixing this is described here. And those country facts, they're completely arbitrary and they don't reflect any particular opinion towards that particular country. Just saying. We assume that for each human visitor, there will be like 1 to 2 HTTP requests per visitor. And that's a norm. So basically, we want to say that everything that's not a normal request will be filtered away. And also, we want to be able to take decisions on either a country level or an AS number level. This is where Cloudflare comes into the picture, and this is what they can do via their API. So their API allow rules based on AS country and just not IPs and ranges. And also the API allows us to remediate via CAPTCHA or JS challenge that's similar arithmetic challenges as only humans supposedly can do. So what happens here in the agent during this attack or during the simulation is that CrowdSec agent will read the log from Apache 2. Then it will identify what is attacked, and then they will send those directly to the bouncer. The bouncer will then activate Cloudflare API, and then firewall rules within Cloudflare will block those connections. And this is a diagram of what happened. You can see around 8:30 the attack starts, network goes up, CPU utilization goes up, and then approximately, how we look at it, 5, 6, 7 minutes later, everything is back to normal. And 2 of those minutes, that's delay internally in Cloudflare. From when you order a firewall rule in their API, it takes 2 minutes before that rule is into effect. I want to talk a little bit about how the internal decision is made within CrowdSec as the attack goes on. The CrowdSec agent groups all HTTP requests by source country, and we only allow requests from 50 distinct IPs per 30 seconds, and this is where the bucket comes in because this is what we call a leaky bucket approach. So once that bucket overflows, then the scenario is triggered. First, CrowdSec will block a whole country if the entire country is deemed bad. Then it will block by AS number, and then it will block every single IP that's malicious until all the malicious traffic is gone. Firewall rules, as I said before, they are created in Cloudflare via Cloudflare API. And what's really interesting about this is, as I said before, it doesn't necessarily block all traffic from the country. By forcing the users to go through a CAPTCHA, that's what we call a fixed rule. That's really what we want to use here. Also because it's somewhat less risky, because the user is never blocked. A real user is never blocked, and that is a really, really strong point here. So the risk of false positives, so to speak, is a lot less. So yeah, let's see how it looks. First off, we'll start the DDoS attack. Then on the top, That's simply the tail of the Apache 2 log. And on the down right, there is the CrowdSec CLI. And as the attack goes by, you'll see how the agents start to identify something going wrong with India, something going wrong with Russia. And you can also see there's a lot of different IPs right now. And there's a lot going on. So it basically says that for those 3 countries and that AS number, it will force a captcha. And it's starting to order those in Cloudflare, and it takes a little time, I've said before. Then gradually, you will see traffic start to slow down. You also see that the traffic will come from fewer IPs, and then eventually there'll only be really few IPs, and over time those will be banned as well. Yeah, just follow on the CLI. More countries are being banned. More IPs are being banned. And as they individually generate more traffic than we allow, then we'll block them. And eventually it will go away. You can see that there's an IP from Hong Kong, there's China, there's Amazon also, and Brazil, or Brazil. The DDoS is now fully mitigated, but the attack still goes on, but we just can't see that looks more like a normal user. Really. Yep. Sorry. Yeah. So basically, that was it. As I said before, we have tried being our founders has tried being a secure hosting company. So we hope, or at least think, that we can build it securely as well. And we also think that this is a really great idea that we really hope the community will catch on to. One of my tasks will be to facilitate building that community and facilitate talking to the community about which features people want and what makes sense, and of course also encourage people to contribute, because you can basically contribute anything. You can go to our GitHub to try it out. You can see the link on my slides. And if you have any questions, feel free to send me a mail. I'll be more than happy to answer all your questions. Yeah, so that's it. You have any questions? Thanks.
Thank you very much, Klaus.
I hope I wasn't stuttering as I feel myself.
No worries about it. So we're going to have like a long break here before the next talk. So in the meantime, like you mentioned that the tool is not yet open source, right?
Pardon?
The tool is not yet open source.
No, everything is not open source. The backend is not open source yet, but
right.
but we want to make it really transparent how the process is made, so that you can see that it's really being done in the way we say it is, and not something else. And also that will also illustrate how hard it is to poison the database.
Right. So you're going to open source that, right? Like more or less, like what is the timeline more or less to?
We're not sure yet. I haven't heard any specific details, and I'm not sure that it's going to be the same open source license, because that is it is this strange mix that we want to have it a little bit closer, but we also want it to be transparent. Yeah. So I don't really know what we're going to do, but we'll think of something that will sort of satisfy both needs, I'm sure.
Awesome. Well, thank you very much. Appreciate your time with us here today. If anyone has any questions, feel free to ask on the Slack channel, or as Klaus said, send him an email. I'm sure he will be happy to answer them.
Yeah. I'll also stay in the Slack channel for the rest of the conference. So yeah, send me an email, or send me a message there, or if there's anything you want to ask about, and if you think that CrowdSec sounds just a little bit interesting, please try it out, because the more users, the more agents, the better threat intelligence, and the better we are able to defend ourselves. And that's the point here.
Awesome. Thank you very much. So we're going to have the next talk in around 17 minutes, more or less. So see you.
Yeah. Have a great conference, guys.
Thank you.
Bye-bye.